Given this equation, a raised to the power of logarithm of 2a equals 5, then the goal is to find the numerical value of a. Now pause this video right now and see if you can answer this question. By the way, this logarithm is in base 10. Now, if you're done, post your answer in the comment section down below because I will show the solution in 3, 2, 1. Alright, so given this equation, a raised to the power of logarithm of 2a equals 5, wherein this logarithm is in base 10, then the goal is to find the real value of a that satisfies this equation. Alright, now let's get this equation, and what we're going to do is to use some properties of logarithm. So first, let's get the logarithm of both sides. So logarithm to the base 10 of a raised to the power of logarithm of 2a equals logarithm of 5. Now, we have here an exponent, so we can put this exponent in the front like this. And now let's focus on this result. Because we have here logarithm of 2a, so what we're going to do is to use this identity. If we have logarithm of n times m, we can rewrite this as logarithm of n plus logarithm of m. So we can rewrite this as logarithm of 2 plus logarithm of a. Now, we can now distribute this logarithm of a to logarithm of 2 plus logarithm of a. So we have logarithm of 2 times logarithm of a plus logarithm of a raised to the power of 2. Now, this 5 right over here, to use this, what we're going to do is to use this 5 and rewrite this as 10 over 2. Because since it is in base 10, logarithm of 10 is just equal to 1. And also, we can use another identity, logarithm of n over m, simply equal to logarithm of n minus logarithm of m. So we can rewrite the right-hand side as logarithm of 10 minus logarithm of 2. And we know this is just 1. Now, let's focus on this result. And what we're going to do is to equate this to 0 or rearrange some terms a little bit. Because take note, in this expression right over here, we have here a common term, a common factor of logarithm of 2. And on this term, we can factor this out because this is just the difference of 2 squared. Because this one here is 1 squared. We can write this as 1 squared. Now, factoring out logarithm of 2 in this 2 expression, we have here logarithm of 2 multiplied by logarithm of a plus 1. And using the difference of 2 squared, we have logarithm of a minus 1 multiplied by logarithm of a plus 1. And take note, we have here another common factor of logarithm of a plus 1. So again, we can factor this out nicely. And since it is equal to 0, at least one of them must be equal to 0. So for case number 1, logarithm of 2 plus a minus 1 equals to 0. And the second case, logarithm of a plus 1 equals 0. And of course, let's focus on these two cases. And let's solve for the value of a because this is what we want to find. Alright, now on this first case, let's isolate logarithm of a. So we have logarithm of a equals 1 minus logarithm of 2. Now we can rewrite this one as logarithm of 10. And again, using some properties of logarithm, we can combine these two logarithms as logarithm of 10 over 2. And 10 divided by 2 simply equal to 5. And comparing the left-hand side and the right-hand side, we can clearly say that a equals 5. So we found one solution or one value of a that satisfies this equation. So we know a equals 5. Now, on the second case, logarithm of a plus 1 equals to 0. So logarithm of a equals negative 1. And then this one right over here, we can rewrite this again as logarithm of 10. And we can put this exponent, negative 1, in the exponent of 10. And 10 raised to negative 1 is simply equal to 1 over 10. Therefore, comparing the left-hand side and the right-hand side, we can say also that a equals 1 over 10. And this is the two possible values of a that satisfies this equation. And of course, here's the checking for those two values of a. So when a equals 5, 5 equals 5. So the left-hand side and the right-hand side balance. And also when a equals 1 over 10, the left-hand side and the right-hand side also balance. They're both equal to 5. Therefore, given this equation, a raised to the power of logarithm of 2a equals 5, then we found two values for a. We have a equals 5 or a equals 1 over time. And as always, we are done.